Alright guys, so we have seen string hashing, that is just comparing two strings, right? Just comparing two strings whether they are equal or not. So the normal time complexity was O of minimum of n1 comma n2, right? And then we used something called as polynomial role hashing function, right? There's a very bigger problem in computer science, and most widely, this is observed in many cases. Your search engines, your compilers, your editors. In all these cases, this is used. That is known as pattern matching problem. Pattern matching का मतलब ये होता है that I will give you a text, a long text, and I will give you a pattern. Right? You just have to identify कि that pattern उस text में कितनी बार आता है और कहाँ आता है. Is this thing clear? There are two things. One is text, second is pattern. So you just pattern matching algorithm मतलब pattern matching algorithm, right? So you just have to match the pattern in that text, and you have to return to me कि that pattern how many times can you observe it in the text and at what index, right? So you could see, right? It has wide applications, editors में या control F करते हो, right? You just control F करते हो तो क्या कर रहे हो? You're trying to find the word in that entire document, then that entire document becomes the text. Very clear? Are you clear कि it's a very important algorithm? Right? So what if I tell you have to write a pattern matching algorithm? तो आप क्या करोगे? आप pattern को लोगे and you will start comparing character by character at every location. Right? Yes or no? So let us see something called as KMP. उसके पहले let us see the naive algorithm, मतलब the brute force. Right? In brute force, what you will do? You will align the pattern at every position in the text and compare the character one by one. Right? So, जैसे I have a dog. Right? This is the text. I have a dog. His name is Tom. Right? And your pattern is DOG. तो आप पहले D और I को कंपेयर करोगे, नहीं मैच हुआ, आगे बढ़ोगे. तो I have H और D को कंपेयर करोगे, नहीं मैच हुआ, आगे बढ़ोगे. You will keep on comparing, right? And match हो जाता है, तो then you will find a match, you will return the index, and you will increase count plus. Very clear, very simple, just for loops, right? So what do? You align the pattern at every position in the text and compare characters one by one, right? And rechecking same characters multiple times. So इसके साथ issue क्या करता है? Let's say आपका pattern looks something like this: A, D, right? Sorry, the text looks something like this, right? And your pattern looks something like this. So what is happening is आपने A और A कंपेयर किया, right? Again A और A कंपेयर किया, फिर A और B it didn't match. So obviously there is no pattern matching starting from this A. You know that for sure. Now what you will do? You will move on to the next character and again start comparing from the start point. Remember this thing, a very small nuance, and this is what KMP is all about. Right? It will get a bit tougher, and last we will realize that all the method, all the hard work that we are putting in is just to avoid this. Are you getting what's happening? A match, A B, it did match. Now you know starting from this you have no pattern. Now you move on to this A, right? And again starting से आप match करना start करोगे. Again A match, A B. It didn't match. Then again you move on to the next, and again you start from the start. A. ऐसे करते last में you will get a pattern matching, something of that sort, right? So can you tell me the time complexity? Worst case, if this is of size n, pattern is of size n and text is of size m. Exactly. Are you trying to मतलब visualize हो पा रहा? It's n into m. क्योंकि आप मैच कर रहे हो, फेल हो गया, वापस यहाँ पे स्टार्ट पे आ रहे हो और इसके नेक्स्ट कैरेक्टर पे जा रहे हो, वापस मैच कर रहे हो, फेल हो गया, वापस स्टार्ट पे आ रहे हो. तो एवरी टाइम एवरी कैरेक्टर के नेक्स्ट से स्टार्ट कर रहे हो. तो वर्स्ट केस में क्या हो रहा है? n into m. Very clear? O of n into m. Can you imagine n into m? And KMP reduces this to n plus m. Now that's something revolutionary, right? N into m. Just imagine n and m are large numbers because text is a whole document, right? So n can be, let's say, 2048 characters long, and pattern can be, let's say, 128 characters long. So 2048 into 128, कितना हो जाएगा? 2048 is 2 to the power 12, right? 128 is 2 to the power 7. Yes. So 2 to the power 12 into 2 to the power 7, 2 to the power 19. This is brute force, and KMP is just addition of both of this. 2 to the power 12 plus 2 to the power 7, right? Way lesser than multiplication, because that goes 2 to the power 19. Very clear? The difference is huge, right? So what is something special that KMP does? KMP is the name of 3 scientists, Morris and Pratt, right? Who together invented this algorithm, right? So obviously it's an efficient string matching algorithm. It's a string matching algorithm which is efficient. You search for a pattern within a text. Obviously that's the problem definition itself. You search for a pattern within a text. Now pay very close attention. Things are going to get very interesting. It uses a pre-processing step to handle mismatches smartly and achieve linear time complexity. Alright, just try to understand this. We'll prove it later. What does it say? It uses a pre-processing step. You do some pre-processing, right? What pre-processing? That we'll see. It uses a pre-processing step to handle mismatches smartly. यहाँ पे इशू क्या हो रहा है? जहाँ पे mismatch हो रहा है, आपको वापस back to square one जाना पड़ेगा, right? Just imagine कि n size का pattern है, n-1 तक match हो गया, सिर्फ nth index match नहीं करा, तो आपको next iteration में वापस 0 से start करना पड़ रहा है, right? So this is what the pre-processing helps. What pre-processing helps you to handle mismatches smartly and achieve linear time complexity. O of n plus m is linear, right? Very clear until here. Now firstly we will see what is the pre-processing step. Alright, just bear with me. Alright. So firstly let's understand what's a proper prefix. Prefix and suffix आप जानते हो? Prefix starting से, right? A part, a substring of your major string. Suffix ending at that substring, right? What is a proper prefix? A, B, C, D के proper prefix are empty string, A, B, and ABC. Empty string A, B, and ABC. This is proper prefix. The entire string is not considered as a proper prefix of that string. Very clear what is a proper prefix? Now, try to understand something which is LPS, right? So, okay. What do we do here is, in the pre-processing step, we create an LPS array. Okay? What is an LPS array? Okay? It stores for every position in the pattern. Firstly, always remember one thing, we are pre-processing pattern, not text. Why? Because obviously pattern would be way smaller compared to text, right? Text को pre-process करके क्या ही करोगे? आपको pattern को बार-बार text में ढूंढना है. तो अगर आप pattern को कुछ pre-process कर लो, that would help you more, right? Text को pre-process करके what you will do? Is this thing clear? So you are pre-processing pattern. How you are pre-processing pattern? You are creating an LPS array, right? What is that LPS array that you will see? It stores for every position in the pattern. For every position in the pattern, मतलब LPS array का size क्या हो गया? Same as the size of your pattern. Yes or no? Right? Same as the size of the pattern. It stores for every position in pattern length of longest. Listen to me very carefully. Length of longest proper prefix which is also a suffix. At every position in the array, it stores what? Length. Length of what? Proper prefix which is also a suffix. Cool? Right. Of the substring ending at that position. Of a substring ending at that position. Right? Let us see this. AAB, AAAC. Right? For every position I have to calculate what will I store in the LPS array. Right? So always remember कि 0 के लिए 0 होगा, right? Because A का proper prefix कोई है ही नहीं ना, it's just an empty substring. आप बोलोगे सर A का proper prefix A है नहीं, it's a prefix, not a proper prefix. I told you कि proper prefix does not include the entire string, right? Now just focus on this A, right? Now can you imagine कि इसका एक A का proper prefix क्या है? Empty substring and A. Yes or no? Empty substring and A और suffix क्या है? A. तो अगर आप देखोगे तो A और A match कर रहे हैं. There is a proper prefix which is also a suffix. So LPS में store 1. Right? ये the more examples we will see, the more clearer it will get. Right? अभी A, A, B. What are the proper prefixes of A and B? Empty string छोड़ दो. A and A. What are the suffixes B and AB? Is there anything matching? There is no proper prefix which is also a suffix. तो यहाँ पे क्या आ जाएगा? 0. Now A, B, A. What are the prefixes? A, and B. And there is a suffix which is just A. So you have A and A matching. So the length क्या है उसका? A का 1. Now see B double A. What are the prefixes? A, B, and B, A. And what are these are the prefixes? What are the suffixes? A, and B, and also this. But if you see A and A, isn't this a proper prefix which is also a suffix? Right? So what's the size of that? 2. So I store 2. Now let's move on to this. AAB triple A. यहाँ पे भी आप देखोगे there is a proper prefix double A which is also a suffix. Double A. So again 2. Now if you consider this entire thing, there are a lot of prefixes possible for A, B, A, C. Right? But ऐसा कौन सा भी prefix है ही जो C पे end कर रहा होगा? क्योंकि suffix will always end at C, right? Yes or no? Yes. Very clear. So वहाँ पे 0 आएगा. Now try to calculate for this. A 0, AB 0, ABC 0, ABCD 0, ABCD A 1, this A and A 1, ABCD A B, AB, so 2. ये पूरा आप चेक करोगे तो ABC 3 and लास्ट में वापस A आ गया तो सिर्फ A और A 1. Right? Is the idea of what is the definition of longest prefix which is also a suffix? That is what LPS means. Is clear? Okay. ठीक है. Stage 1 is clear और 2 stages है. Right? How to calculate this LPS array? Right? Efficiently is the question. Right? So see, I hope this is visible. Right? So you traverse the pattern from index 1 क्योंकि LPS of 0 is 0. So you traverse the pattern from index 1, right? And you compare pattern of I with pattern of length. What is length? Length is initially equal to 0 and length is what? It keeps track of the length of the previous longest prefix suffix. Previous longest prefix suffix ताकि आप वो यूज कर पाओ. जैसे यहाँ पे जब मैं A B C D A B C पे पहुंचा था, right? And I know the answer until this point. A B C D A B इसका आंसर मेरे को पता था 2 है, right? अगर मेरे को सिर्फ C एक्स्ट्रा ऐड हो रहा है, राइट, तो आई कैन कंपेयर दिस विद दिस. अगर ये दोनों इक्वल है, राइट, तो प्रीवियस के लेंथ में मैं 1 करके सीधा 3 लिख सकता हूं ना. दिस इज व्हाट योर ब्रेन वाज डूइंग, राइट? आई एम रिपीटिंग. आप जब कैलकुलेट कर रहे थे तो A B C D A B C स्टार्टिंग में आपको मुश्किल हो रहा था. फर्स्ट टाइम यू आर लिसनिंग तो यू आर सीइंग प्रॉपर प्रीफिक्स एंड सफिक्स. बट जब ये पूरा भूल जाओ, ठीक है, A B C D A B इसका आंसर 2 है. मतलब A B and A B is equal, right? Now next is C. What if I directly compare this with this? If this is equal, तो यहाँ पे क्या आने वाला है? प्रीवियस का जो था उसका +1, right? Let's say A B C D E, A B C D E, right? Just imagine A B C D E, A B C D E. तो यहाँ मैं D तक पहुंचा. What's the pattern? A B C D E, A B C D. तो D पे प्रॉपर प्रीफिक्स सफिक्स क्या है? 4, क्योंकि A B C D मैच कर रहा है. अब इसके आगे का E यहाँ के E के साथ मैच कर रहा है, तो मैं सीधा 4 + 1 5 लिख सकता हूँ, राइट? क्लियर? राइट? नाउ उसी को कोड में कैसे लिखेंगे? दैट इज व्हाट आई हैव रिटन हियर, राइट? यू ट्राई. नाउ यू अंडरस्टैंड व्हाट इज लेंथ. लेंथ इज यू कीप द ट्रैक ऑफ द लेंथ ऑफ द प्रीवियस लॉन्गेस्ट प्रीफिक्स सफिक्स. जैसे यहाँ पे रखा था दिस एग्जांपल में 4, तो आपने सिर्फ +1 कर दिया और 5 लिख दिया. यस और नो? राइट. सो नाउ केस 1, व्हिच इज दिस केस. व्हाट इज द केस? पैटर्न ऑफ i इज इक्वल टू पैटर्न ऑफ लेंथ, राइट? लेंथ वाज व्हाट 2, तो पैटर्न ऑफ लेंथ क्या हो जाएगा? 0 1 2. एंड पैटर्न ऑफ i c, तो पैटर्न ऑफ i एंड पैटर्न ऑफ लेंथ इज इक्वल. Yes or no?
Yes, sir.
Pattern of i, pattern of length is equal. Then what you are doing? Length plus plus कर दिया आपने, और LPS of i क्या आ गया आपका? Length आ गया. So that is what I have written here. If pattern of i is equal to pattern of length, length plus plus LPS of i equal to length and i plus plus. You are moving on to the next. Right? Now things get interesting. There are two different cases now. Right? Pattern of i is not equal to pattern of length, right? Just imagine यहाँ पे f था. Suppose यहाँ पे f था, right? Okay, यहाँ पे f था. तो can I say pattern of i is not equal to pattern of length, right? And let's say length is also equal to 0. Length is also equal to 0. So in that case, length is also equal to 0. Can I directly say LPS of i will be equal to 0? क्योंकि इसके पहले कोई प्रॉपर प्रीफिक्स था ही नहीं जो मैच कर रहा हो, राइट? मतलब A B C D E F G जो भी है, तो लेंथ इज 0, पैटर्न ऑफ i एंड पैटर्न ऑफ लेंथ दे आर नॉट इक्वल, राइट? सो यू कैन डायरेक्टली राइट LPS of i equal to 0 and you can move to the next point. Things get interesting when this happens. Pattern of i is not equal to pattern of length and length is greater than 0, right? Just bear with me, right? Let me create an example which matches this. Let's say A B C, right? A B C, so C and C matches. Let's say that right? Let's say this is the case CDC. तो इसका LPS है, क्विकली बनाओ तो क्या बनेगा? 0 0 1. ये 2 नहीं होगा, 1 होगा, then 2, then 3 ना, CDC. Now यहाँ पर क्या है, right? यहाँ पे if you see D and 0 1 2 3, so pattern of i, pattern of length is not matching, right? But your length, previous length क्या था? 3. Length what does it store? Previous longest prefix suffix. So at this case, this is like length, this is i, right? and length is equal to 0, 1, 2, 3, right? Now see, why is this a different case? यहाँ पे D और C मैच नहीं कर रहे, पैटर्न ऑफ I is not equal to पैटर्न ऑफ लेंथ। इसके पहले वाले केस में पैटर्न ऑफ I और पैटर्न ऑफ लेंथ इक्वल नहीं था, बट लेंथ 0 था, तो इसीलिए आपने LPS ऑफ I 0 कर दिया। यहाँ पे ये दोनों मैच नहीं कर रहे, बट लेंथ 0 नहीं है, लेंथ क्या है 3 है, तो व्हाट डू यू मूव ऑन टू दो उसके प्रीवियस का क्या मैच हो रहा था, so that is 2 and therefore you get this CD is equal to this CD. Let it sink in, right? Pattern of I, see, I am repeating, pattern of I और pattern of length equal है, जैसे this case AB CD AB और यहाँ पे C extra add हो रहा है, तो this C and this C is matching, right? So what did you do? Length plus plus और LPS of I equal to length कर दिया, 2 था 3 हो गया, 3 स्टोर कर दिया और I plus plus कर दिया, very clear? Then second case is also easy, कि pattern of I और pattern of length equal नहीं है, the characters don't match. I know it's heavy but just bear with me. The characters don't match but the length is also 0, क्योंकि उसके पहले ऐसा कोई prefix था ही नहीं जो suffix के equal है, तो obviously 0 ही आने वाला है। Now those two characters don't match, but उसके पहले ऐसा कोई prefix था जो suffix में return हो रहा था, तो इसीलिए I'll have to check उसके previous वाला। So that is the reason if pattern of I is not equal to pattern of length and length is greater than 0, so I just update length as LPS of length minus 1, right? I'll update length minus 1, right? And then I'll just compare. Again I have to compare. Is this thing clear? You will have to work on it now. You will have to work on it. It's not that easy. The third case is a bit tricky, right? Let's see an example. ठीक है, चलो A0, we are just creating an LPS array. एक last case बचा है, just bear with me. Just create an LPS array between length is 0. Follow that algorithm now. Follow that algorithm step by step, बहुत clear हो जाएगी चीज़, right? Length is 0, AB 0, right? I move I here, length is 0, A and B doesn't match, 0. I here, character matches, right? So what you do length plus plus. What I'm trying to tell you is कि ये intuition से मत solve करो, algorithm से solve करो, तो algorithm और intuition match हो जाएगा, right? What did you do? Length plus plus. वही बोला ना मैंने, पहले length plus plus करो और फिर LPS of I में क्या store करो? Length. तो यहाँ पे क्या जाएगा? 1, right? Now I. Does this match? What will you do? Length plus plus and I. And what will this be? 2. Obviously 2 है, AB and AB. Next double A के लिए क्या होगा? यहाँ पे again the first case it matches, right? So सबसे पहले length plus plus, so that is 3 and LPS of I is equal to 3. Very clear? Now let's do I plus plus हो जाएगा. Does it match? No, but what's length? 3. अगर length 0 होता तो मैं सीधा LPS of I equal to 0 लिखता, right? Now listen to very carefully. It doesn't match 0, but length is 3 है. 3 है, 3 है ना length? हाँ, तो अभी मैंने क्या लिखा, क्या करना है आपको? Length को अपडेट करना है LPS of length minus 1. Length was 3. What is LPS of length minus 1? LPS of 2, which is 1. तो आपका length अपडेट हो गया 1 के लिए, तो length is now pointing to this. Now repeat the algorithm. Length क्या हो गया? 1 हो गया, तो length points to this. Now repeat the algorithm. A and B match हो रहा है? नहीं हो रहा है. So but length is greater than 0. Length is 1, so it is greater than 0. Now what you will do? Update length minus 1. LPS of length minus 1. Length minus 1 is 1 minus 1, which is 0. Right? Then your length becomes 0. Now you will compare A and A. It matches. Right? और अगर मैच हो रहा है तो length plus plus and LPS of y equal to length. तो length 0 था plus plus होके 1 होगा and LPS of y equal to 1. Understood? Yes, sir. This is just the pre-processing. Now you have pre-processed the data. कोई मेरे को भी बोल सकता है कि ये इतना क्यों किया? Why did we go through all this pain? Sorry? हाँ, तो कैसे हो रही है कम? We'll see that algorithm as well. But कैसे होगी कम? ऐसा क्या हो रहा है? What is so special about longest prefix which is also a suffix? लेक्चर स्टार्ट किससे हुआ था? इशू क्या था नाइव एल्गोरिथम में? वापस स्टार्टिंग से स्टार्ट करना पड़ रहा था. तो लॉन्गेस्ट प्रीफिक्स व्हिच इज आल्सो सफिक्स का फायदा क्या है? कोई सोच सकता है? वी कैन स्टार्ट द नेक्स्ट. एग्जैक्टली, वी कैन यूज द एलपीएस एरे टू स्टार्ट द नेक्स्ट पैटर्न मैचिंग जहां पे भी फेल हो जाए, नॉट फ्रॉम द वेरी स्टार्ट, बट ऐसा सफिक्स जो प्रीफिक्स के इक्वल है तो मैं उतने कैरेक्टर स्किप कर सकता हूं. हाउ? लेट अस सी. दिस इज द टेक्स्ट, दिस इज द पैटर्न. इसका एलपीएस एरे बनाओगे तो ऐसे बनेगा. राइट? ए बी सी इज द पैटर्न. एलपीएस एरे क्या बनेगा? 0 0 A1 AB 2 C 0. Now see, A match, BB match, AA match, BB match, AC didn't match. Now what I'm trying to say is this was matching until this point. Just try to first visualize this, right? This is matching until that point. Now, अगर normal algorithm होता तो what you would have done? Fail हो गया, अब वापस A और B match करने का try करो, right? That becomes n into m. Yes or no? Yes. So what basically I am trying to say is, if the characters match, you move. What's the algorithm saying? If the characters match, move forward in both text and pattern. If the characters match, move forward in both text and pattern. If it doesn't match, then you use the LPS array, LPS value, and you move on to the previous value. इसका previous, this doesn't match, so LPS of this is let's say I, and this is let's say J. So ये match होते क्या? You are here, I is here, and J is here. Very clear? I is there and J is here. Now this doesn't match. नाइव एल्गोरिथम में अब वापस स्टार्टिंग से इसको मैच करने का ट्राई करते हैं, तो n into m हो जाता है, राइट? नाउ व्हाट आई एम डूइंग इज j-1 का LPS वैल्यू देख रहा हूं मैं जो कि 2 है, राइट? सो सिंस इट्स 2 आई कैन डायरेक्टली स्टार्ट मैचिंग फ्रॉम दिस. व्हाई? बिकॉज़ C A B C मैच हो रहा था. अगर सिर्फ j-1 का मैं LPS देख रहा हूं वो 2 आ रहा है, what's the meaning of that? कि there is a length 2 prefix which is also a suffix which is nothing but AB and AB. Now just imagine this, कि ये पूरा ऐसे कैसा मैच हो चुका है. Just pay very close attention ना, ये पूरा ऐसे कैसे मैच हो चुका है, राइट? इसका मतलब ये पूरे स्ट्रिंग का कोई सफिक्स है जो इस टेक्स्ट के सफिक्स के साथ मैच हो चुका है. So this suffix is matched with this suffix. Yes or no? This AB is already matched with this, and I already know that there is a length 2 का suffix which is also a prefix. So there is a length 2 का suffix which is also a prefix. So if this is matching with this and this is matching with this, मतलब let's say this is A, this entire thing, this is A, this is B, and this is C. So what I know, A is equal to B. They are same. then a length 2 का suffix which is also a prefix. So this is equal to this. So I know B is equal to C. Now can I say A is equal to C?
Yes.
So why do I match it again? No need, right? That's the beauty of this algorithm. See, this AB is matching to this AB. Now I know this AB is matching to this AB. So I could skip comparing this and move ahead. Did you get it? ये तो बहुत छोटा एग्जांपल हो गया. आप ऐसा समझो कि आपके पैटर्न में बहुत सारे प्रीफिक्सेस और सफिक्सेस मिल रहे हैं. तो जस्ट इमेजिन अगर किसी LPS एरे में 12 स्टोर हो जा रहा है तो आप सीधा 12 के 12 कैरेक्टर्स का कंपैरिजन अवॉइड कर सकते हो. डू यू गेट दिस? Yes or no?
Yes, sir.
So yeah, and the time complexity of this comes out to be 4. Very clear? KMP, pattern matching algorithm. You pre-process what? Data or pattern? Data is text. You pre-process pattern. Pattern में what do you create? LPS array of the same size as the pattern. LPS of 0 को 0 store कर देते हो. LPS is what? Longest prefix which is also a suffix. उसका algorithm we did see. How do you do it? Length equal to 0 से initialize करते हो. Right? 3 different cases. And last में फिर LPS array निकालने का फायदा क्या होगा? You can skip those characters and move directly ahead. Right? So it doesn't become n into m. It gives you linear time complexity which is O of n plus m. Right? Pattern matching is used in a lot of cases. Text editors, compilers, or search algorithms. Right? Very clear?